So, hello everyone, good afternoon. This is our first session for the course Material and Energy Balances, and I am a TA for this course, Mochandra Paul. I'm actually a PhD student in IIT Kanpur in the Department of Chemical Engineering. So, as part of my PMRF fellowship, I am doing this TA work for you. And in this session, I'll help you guys by solving few problems. And at the same time, I'll try to answer your queries as well. And my research, I've been working in the area of tissue engineering and 3D bioprinting. And my website is there on your screen. You guys can go and look at my research and previous teaching works that I have completed. And if you have any queries related to the course content and all, feel free to post them in the course discussion forum. And also feel free, don't be shy to, reach out to me in any queries. I have given my email ID as well on the screen. Also, this meeting platform that we are using right now, it does not support chat, all right? Just does not support chat option. So if you have any doubts, you have to unmute yourself and tell it yourself. And like you can also raise your hand in order to respond to few questions from time to time so that I know that you're present and you're able to understand whatever being discussed. So these sessions will be conducted till the end of the course. It's is this it will be on every Saturday from 3 to 5 p.m. The meeting link and everything will remain the same. All the sessions will be recorded, starting with this one, and they will be uploaded in my YouTube channel. This is the link of my channel. You guys can go ahead and subscribe if you want so that you get notified that the recording has been uploaded. And the notes for these lectures that we are doing, they will be available in the Google Sheet soon. So PMRF NPTEL team, so the NPTEL team basically will share this Google Sheet as well in the course platform, and from there also you can access the notes. So notes and recordings, everything will be made available to you in the meantime, okay, as we are progressing. And in every session, I'll be noting down the people who are attending so that I will be reporting to the NPTEL people, right? So as discussed, there is no chat option. So if you have any queries, you have to unmute yourself and speak. And also, I would request you to keep yourself muted if you're not speaking anything, right? Otherwise, it causes unnecessary disturbance during the meeting. If you have something to speak, you can unmute yourself, all right? So before I begin with the questions, so I've prepared like 10 questions for today's session, and I think we will be able to finish it up. But I would like to understand about you. So I see two people have joined. So can you tell me a bit about yourself? Like, what's your background, and why did you decide to do this course or enroll for this course? I'm sorry if one of you is speaking, I can't hear you. As I said in the beginning, don't feel shy. It's totally fine to be open. Discussions makes much more good environment for learning. So don't be shy. Any one of you can volunteer and introduce a bit about yourself, like your name, where are you from, and what are you studying right now, and why did you choose to enroll in this course? Again, I can't hear you. If one of you is trying to speak, I can't hear you.
Good afternoon, ma'am.
Good afternoon. Yes.
I'm myself B. Sharmata from Pallipalayam,
And what are you studying right now?
B.Tech Chemical Engineering, second year, ma'am, Mahendra Engineering College.
Okay, okay. So why did you decide to do this course or enroll for this course?
From parents' suggestion.
Parent suggestion. Great. Okay. So I just want to ask one more thing. Since you're in chemical engineering department, did you already learn a course similar to this one?
Yes, ma'am.
Okay, great. Uh, what about the other guy who has joined? Can you introduce a bit about yourself? Okay, seems like uh, you're very shy. It's fine. So let's begin. Okay, this is the first question. So first thing, all the questions that we're going to discuss is based on the content of week one. So it if you have gone through the video lectures of week one, then you'll be able to relate to these questions a bit more, okay, as I'm solving. I'm assuming, by the way, that you have gone through the video lectures. And if you have not, can you guys let me know so that I can decide how brief or how thorough I have to be in my explanations for these questions? Again, I'm asking, have you guys gone through the video lectures of week one? Maybe partially or one, two, like 20%, 10% of it. Anything? It's fine if you say no as well. Okay. I think, again, you got so shy to speak up. So it's fine. I'll assume that you have some idea of the content that is being discussed in week one. Okay. And I'll try to give as much explanation as possible for when I'll solve each of these questions. But you have to let me know whether you have doubts or not in each question at the end of each question. Okay. If you have doubts, I'll go through your doubt point, okay, and try to explain it in a much better way. Okay. So this is the first question. This question is based on the topic of significant digits and how to count significant digits, how to do arithmetic operations, okay, like addition, subtraction, multiplication, divisions, using digits like this, and then determine, write the number up to let's say 2, 3, like you have to determine how many significant digits is required for that particular calculation. Okay, so this is the arithmetic operation that is given between two numbers. All right, so this is we are doing addition of these two numbers, and after doing additions we have to say how many number of significant digits are there. Okay, what are significant digits? Anyone? So if you recall from the lectures, we so let's categorize numbers first. If the number does not have decimals, like whole numbers, let's say 1500, this number does not have decimals. Now, how many significant digits are there in this number? It's 2. So the rule of thumb is, for these type of number where there is no decimal point, we have to count the first non-zero digit from the left hand side up to the last non-zero digit. So there is two non-zero digits. So so that means there are two significant digits. Whereas numbers with decimal point in it, let's say 432.3 50, 432.50. Okay, so for these type of numbers, how will you count the significant digits? So here the rule is that you have to start counting from the, again, first non-zero value, non-zero digit, first non-zero digit, that is from 4 till the last one. So how many significant digits are there in the second number? How many significant digits are there in the second number? Is 4. So you have to start counting from the first non-zero number to the last one, even if the last one is 0. Okay, sorry, not 4, there are 5. Okay, so in this way we like count the significant digits. Now we have, when now in this question we are doing addition between two numbers. So first, using our calculators, if you have a calculator in front of you or you have your mobile phones with the calculator, you can add these two numbers, right? So if you add uh 10 is 1010 plus 75.5, what you get? What you get is 1085.5. Okay. Now in this number, you have to now tell me how many significant digits are there.
Ma'am, 5 digits.
Okay. So here we have to do one thing. When we do additions between two numbers, we have to first see how many significant digits are there in each of them. So the first number has two significant digits, all right? whereas the second one has three significant digits. Okay, so we have to write this answer that we got, that is mathematically correct, in such a way that we uh, get significant digits equal to 2. Means we should write it as, we can round it off to close to 11. Okay, so this means now after rounding off we get the significant digits, that is 2. So again, let me repeat what are the rules there. I think you guys have not gone through the lectures, so I have to bit more thorough. Okay, so let me show you first, before we go and start solving these questions. Let me show you the lecture slides where Professor Vignesh has discussed this. So if you can see the screen, the first slide that I'm showing shows how to count the number of significant digits, right? The first point, as I said, if the number does not have decimal point in it, then you have to start counting from the first non-zero digit on the left side to the last non-zero digit. First non-zero to the last non-zero digit. So for example, 9547. This is the first number. So here there are now 4 significant digits. Whereas in 9500, there are 2 significant digits because we are only counting up to here, 9 and 5. Whereas if there is a decimal point, then how will you count? You will count from the first non-zero digit to the last digit. Okay. So if you see in this example, 9.5470, here how many significant digits are there? There are 5. We are counting up to 0. Whereas in the second example, we have to start counting from the first non-zero digit. That is, we'll start counting from 9. So then it will have then 4 significant digits. Now, if we do operations on them like multiplication, division, okay, so for those operations, we have to first see each number that is being multiplied and divided together, how many significant digits are there individually. So in this example, the first number has 4 significant digits and the second number has 3 significant digits. So which is lowest between the two? It's 3, right? So when you mathematically calculate the answer, you have to bring down the answer to have only 3 significant digits. Got it? Similarly, same rule applies when you are doing division as well. So you have to again check how many significant digits are there in each of the numbers. So the first number here has the 17.1. It has 3 significant digits. The second number has 4 significant digits, whereas the denominator has 5. So this is mathematically, this is the correct answer. But you have to round it off in such a way that the final answer has the lowest of the uh, significant digits that you saw in the numbers that you started with. So the rounded off value will have now 3 significant digits only. Similarly, when you do addition, okay, then addition or subtraction, okay, so like for this example, if you see, the first number has the first number has digits up to the thousandth digit. Second number has digit up to the 10,000 digit after decimal, whereas third one has decimal point up to 100. So when you do the addition or subtraction, like when you solve it, you get this value in your calculator. But the final answer will have how many significant digits now? Close to this one, the lowest one. So it has 4, right? So we will write it in such a way. So we will write it in such a way that the decimal point is up to 100. So that's why the final answer will come close to 14.77. Means lowest of the last significant digits that you saw. Okay. Any doubts here? Anyone, any doubts here?
No, ma'am.
No? Okay. So let's revisit the first question and start again. Okay, we'll start again. This time, uh, you try to do it as well with me. So when you add these two numbers, we in the calculator, what you get? Anyone? You get 1085.5. We just saw, right? So what we have to do? Now here the first number, it does not have any decimal point. The second number has decimal point. But then the last rule that we saw in the previous slide, that won't follow. But we will count the significant digits first. The first number has 4 significant digits, whereas the second number has 3 significant digits. So the final answer will be rounded off in such a way that significant digit is 3. So we will get 109. Okay. So I think then the correct answer for this question is B. Is it okay? Later on, at the end of the session, we will go and have a look at the answer key that I have prepared. Okay. But for now, uh, you also do it, and I am also doing it so that we can match our answers. And later on, we'll see what's the actual correct answer. Okay. So what did you get? Is it 3 for you as well? Yes. Anyone? 3, right? You can respond with a thumbs up if it's okay with you. You understood why it is 3? Okay. Since we have only 2 hours with us, I'll assume that you have understood. Okay. And I'll move on. Now, this is another question based on the same concept. Here you have to subtract now. So get your calculators with in front of you and tell me what is the value that you get after subtracting these two numbers. What's the value you are getting?
Ma'am, 7,999.82.
7 point
7,999.82.
to the 9. Sorry, I'm not getting. To the 9.82. 7.82, right? 7.82, right? Correct?
No, ma'am.
So can you tell me what numbers you have put in your calculator? Is it 8 minus 0.18?
Ma'am, 7,999.82.
7. Okay. I think you're doing some mistake in your calculation here. Uh, 8.00 basically means 8. Okay. So you have to just subtract 8 minus 0.18. I'm doing it in my calculator and I'm getting
Ma'am,
7 point.
7.82.
Yes, yes, yeah. So this is the value that you get in your calculator, but you have to write the answer up to the significant digits, correct number of significant digits. So the first value, how many significant digits are there? It's 4. Okay. Whereas in the second number, it's 2. So we have to express your final answer in terms of or up to 2 significant digits. So the answer will be close to 7.8. We are rounding off, so it is close to 7.8. Okay. No, no, here significant digits will be 3. Sorry. Here we will use the rule where we will match the number of digits after the decimal. So here after the decimal, there are numbers up to 1000th place. Whereas in the second number, the digits are there up to 100th place. So we will express our final answer up to 100th position. So that is why the number of significant digits here will be 3. Got it? This is your 100th position. This is your 1000. So we will choose to express our answer with the digits up to 100th position. Got it? Great. So this is another question again on the same line, but here we have to multiply these two numbers. So multiply 1.729 into 0.0000022. So there are 5 zeros. Okay. Multiply and tell me what's the answer you're getting.
Ma'am, 0.000003803.
Okay. So this is the answer that you get in your calculator, but it is not correct yet. So again, we have to see how many significant digits are there in each of them. So the first number has four significant digits, where the second one has two. So the second one, you have to start counting from the first non-zero digit. So you will start counting from here. Okay. So that's why it is two. So the final answer has to be expressed with only two significant digits. Okay. So the answer here is two. Got it?
Yes, ma'am.
Great. Now, this is another question, question number four. An airline company has announced that the average speed of their Airbus 737, the name of the Airbus, is to be cut from 900 kilometer per hour to 800 kilometer per hour. Okay, to conserve fuel, thus cutting consumption of fuel from 8,000 liter per hour to 7,500 liter per hour. So we have to calculate how many liters of aviation fuel is saved by this Airbus for making a short trip from Coimbatore to Chennai, having a flight length of 450 kilometers. Flight length means basically the distance between Coimbatore and Chennai is 450 kilometers. 450 kilometers. And this plane is going to travel at an average speed of 850 kilometer per hour. So calculate the liters of aviation fuel saved. Okay. So for this, let me quickly add a page. So let's quickly note down what we already know. We know that first point that we understand is for traveling at speed of 900 kilometer per hour, how much fuel is being used? Fuel consumption rate is 8,000 liter per hour for traveling at this speed. Similarly, for traveling at speed 850 kilometer per hour, fuel consumption rate is reduced to 7,500 liters per hour. Now we have to cover from Coimbatore to Chennai. Distance we have to cover, which is close to, which is 450 kilometers. So first we have to understand how much of the fuel is used when you choose the first condition, and how much of the fuel is used when you choose the second condition. And then we will subtract the fuel used from the first condition. uh, we will subtract the fuel used in the second condition from the first condition in order to get the value of fuel or the volume of fuel that you have saved by reducing the speed. Okay, so how will we do that? It's pretty easy. So in case one, when we are traveling at 900 kilometers per hour, and for traveling a distance of 450 kilometers, then fuel used is how much? we have to do a calculation like this, where 8,000 liters of liter per hour is the fuel consumption when you travel at a speed of 900. 900 will go in the denominator. When you travel at the speed of 900 kilometer per hour for a distance of 450 kilometer. So we see I intentionally wrote uh, the units as well. Okay, because that helps us understand, or that helps us give physical meaning to the value that we are going to get after subtraction, multiplication, or whatever operation you are going to do. And that later on you will be able to make sense whether the value that you calculated are having some meaning or not. Okay, so logically, what if you, according to the question, the logic says that if you travel at a very high speed, the consumption of fuel will be more. So let's see whether that is true or not by solving the first case. Okay, so if we do this simple mathematical calculation, can one of you do it and let me know what you're getting?
Ma'am, 4,000.
4,000, yes. So in the first case, when you're traveling at a very high speed, okay, when with high fuel consumption, then for traveling 450 kilometers, you have to use 4,000 liters of fuel. Whereas in the second case, for the same distance, when you travel, the distance is 450 kilometers. Now, your fuel consumption rate is reduced. Why it is reduced? It is reduced because you are traveling at a less speed. So the speed is now 850 kilometers per hour. Okay. So again, we are canceling out the common units, and again, calculate and let me know what's the value of this expression.
Ma'am, 3970.58.
3970.58.
Point five eight.
Okay. So this is in liters. Always remember to put in your units. Okay. Now, as I said, logically, these two values, does it make sense? We have to check when you are doing this kind of problems. So it makes sense, right? If you travel at a less speed, then the fuel consumption is less. So automatically you will use less fuel. So case two that the fuel used value that you got is less than the case one. Okay. So now we have to then calculate how many liters of fuel is saved by making this change. So for this, we will just subtract 3970 from 4,000 and tell me what's the answer that I should get here.
Ma'am, 1.007.
1.007. 007. Can you check again briefly? Because I have done it previously and it doesn't matches with my previous answer. Can you check quickly if you have made any mistakes in it? I'll again wait. 4000 minus 3970.58. I am getting 29.42.
29.42.
Yes, yes, yes. So you have to always cross check. Okay, you have to always cross check your calculations whenever you're doing problems. Sometimes, although we have calculators right now, we are very lucky and fortunate to have those calculators, right? But we can still make some mistakes, in feeding the values and also try to cross check. Okay, so this is the value of fuel that you used. All right. I'll again at the end of the lecture, we will try to, see whether we are correct or not using the answer key. But right now, this is our correct answer. So this is the fifth question that we have. This is a big question. So I'll give you a minute to have a read first yourself. Yes, have you gone through the question? Now let me read it with you, okay, and explain. So meanwhile, if you have any doubts, feel free to interrupt me and we will discuss your doubt first. So water pollution in Ayar River has claimed considerable attention, especially pollution from industrial waste and sewage outlets. The expert team suggestion is to add a tracer of barium ion to a given sewage stream, let it mix well and sample the sewage stream after it mixes. Okay, fine. So on one test of the proposal, you're asked to go upstream, okay, and add 5 kg of sodium boron NaBr per hour for 1 day to a sewage stream with no Br in it. Okay, so they are doing a test of this proposal. So there is a sewage stream. Initially, it does not have any Br ions in it. And how they are adding it? They are adding it later on. Okay, so they are going upstream. They are at the upstream region of the river of the stream, sewage stream. They are adding close to 5 kg of NaBr per hour. Okay, and the downstream, as the water is flowing, the added material will come downstream. And there, when they did sampling, means they uh, removed small amount of this sewage stream and analyzed it. So they got 0.05% of NABR content. So these two are important for us. You will understand why these two values are important for us. I'll show you how. So additional information that is given is the sewage density is 966 kilometer, not kilometer, it's kg per meter cube. And the river water density is this, means river and water, they have similar, what means river water and the sewage has similar density, so we can consider sewage to be water only. Okay, you don't have to think that sewage and water they are separate type of materials. Since they have similar densities, let's consider sewage to be a water, and there is one component water and there is another component Br in our question. Okay, these two are the materials in our question. So what is the flow rate of the sewage in kg per hour at the upstream region? Okay, so let's start solving this problem. So first visualize it. Whenever we do this kind of mass or energy balance questions, we try to visualize the problem in form of a figure where we put in all the values, and that helps us form equations later on, okay, and quickly arrive at our answers. So let's consider this box. This black box is your river, and in is your this is your upstream direction or inlet, and this is your downstream direction, let's say outlet. And here what is happening? Uh, Sewage is flowing, right? Sewage is flowing through this particular box. Let's say at the upstream region, the flow rate of this sewage is denoted by A, is in kg per hour, whereas in the downstream, the flow rate of the sewage is B. It's also denoted in kg per hour. So for understanding, let me write A is the flow rate of sewage in kg per hour in upstream, and B is the flow rate of sewage in kg per hour in downstream. Our question demands that we calculate the value of A. This is your answer for this question. Okay. So what is happening as the sewage is flowing from upstream to downstream direction? We are adding NABR, right? And it is added at what rate? It is added at 5 kg per hour rate. This is the rate of addition of NABR. So let's consider or assume for 1 hour, under 1 hour of time. So this assumption that we are making, this is called basis. And for every material balance type of questions or questions of these type, you have to consider a basis. Why it is important? Let's suppose if you don't say that this process is happening, or the calculations that you are doing is for, let's say, for 1 hour of duration, then it won't have any meaning. um, for second hour, let's say for 2 hours, the value of flow rate can be different. Let's say in 10 hours, okay, after 10 hours, the value of flow rate can be different. So the values keep changing, right? You have to keep something constant in order to define the other conditions. So this is what we are keeping constant, 1 hour, within the duration of 1 hour. we are doing the calculation. And this statement that we made is called a basis. Okay. So within this duration of 1 hour, let's do first the total mass balance for this problem. So mass balance is pretty easy. Whatever is coming in, that the same mass will go out as well. Okay. So in equals to out. So what is going in this case? A, and if you see this diagram, A plus NaBr, it is coming in at the rate of 5 kg per hour. And what is going out? B. Okay, so this entire expression has the common unit, that is kg per hour. Now another material that and we have to since calculate the value of A, and B is also unknown for us, so we need basically one more equation to do our calculation. So for that, let's do BR balance. We'll see how the BR is traveling along this particular process. So BR initially it is absent, right? It is 0. Whereas in the downstream, here I forgot to mention, BR is 0. Whereas downstream, BR is at the mass fraction of 0.005. That is 0.05%. I have written that percent in form of 0.005. Okay, there will be one more zero, sorry. Yes, this is correct, 0.0005. So in the upstream region, there is no BR, and we have added BR. So it's 5 in this direction. This is the direction. If I can draw it a bit more better, then it would make sense. This is going in, going out, and this blue arrow shows that BR is coming in from that upper direction. Okay. And BR is coming out in downstream. What's the mass of it? We have to basically multiply the mass fraction, that is 0.005, with B. All right. So now we have two equations, correct? Here, this is equation 1, this is equation 2. Let's solve first equation 2. So what we see that B is equals to 5 by 0.005, correct? So what is the value of B then? It is 10,000. Okay, it is 10,000. Is uh is it making sense now? And when we substitute this value of B in equation A, so substituting value of B in 1 in first equation, then what we get? We will get the value of A. So A will be 10,000 minus 5, that is 9,995. So what's the unit? It is kg per hour. So there you have it. You calculated the value of A. So this is the value that you needed. This is the flow rate in the upstream region. Okay, understood? Everyone understood? I hope I was not very fast in my explanation. Yes, no, maybe, anything, any response would work.
Ma'am, can you please explain once more?
Once again, okay, great. So uh, here in this question, what we are doing, we are doing mass balance or material balance. Okay. So this black box that you see is the, let's assume this is the river. The inlet is an upstream position from which the sewage is entering at the flow rate of A, which is unknown for us. That's why we noted it as A. And as it is flowing, we are adding NaBr at the flow rate of 5 kg per hour. That is, sorry, let me write again. It is 5 kg per hour. Okay, we are adding NaBr. Okay, that's why I have written it in this way from the top, so that it is different from this one. Or we could have represented it like NaBr is entering from the same direction as this. So we could have done that as well. But for clarity, that's why I've written it like that. And when NaBr is added, we are getting some flow of the sewage in in the downstream direction. But now that sewage, when they have sampled it, it has some Br residues, which is at the mass fraction of 0.0005. Okay, so initially there is no Br, you have added Br, and now the mass fraction that you get is this in the downstream. The question asks you what is the flow rate of the sewage in the upstream direction. That is, you have to calculate the value of A. So before we do that, we have to assume a basis. Means we are assuming here that all this calculation is valid when we are looking at a 1 hour duration. Okay, 1 hour duration of the process. So within for this 1 hour, we are first going to use the law of mass conservation and write the first equation, that is this A plus 5 equals to B. Okay, A is the flow rate, total flow rate containing NABR or whatever, okay, of the mass, plus 5 kg per hour is the NABR mass that is entering, equals to B. This is the total mass, okay, total mass of sewage, total mass of the sewage containing all the components. Now, in this sewage, there is another component that is Br. So we have to now write another equation. Why we first logically we need another equation because there are two unknowns. Okay, so two unknowns, two equations we need to solve the problem. So for that also we are doing this Br balance. But Br is another component in this particular process, so it makes sense, okay, to understand how Br is getting distributed. So upstream there initially there is no Br, so A into 0 plus 5, because we're adding NaBr, so Br is coming at the flow rate of 5 kg per hour is equals to B into the mass fraction of the Br that they got, that is 0.005. This again is forms a second expression. So now the problem is solved. You have written the expression. You have to just do simple maths and find the value of A and B. That's it. So first, as the equation 2 is one has only one variable. So that's why we solved the second equation first. So after solving the second equation, we get the value of B as 10,000 kg per hour. That is the flow rate in the downstream direction. Okay. And when we substituted this value of B in equation 1, so and then we did the calculation, so we got the value of A, which is 9,995 kg per hour. So that is the value that is this question asks. So your problem is solved now. Is it clear? Great. So moving on, this is another question again on material balance. A fish processing industry uses rotary drum dryer for drying the fish cake, after which it is finely ground and packed. Now, in a given batch of fish cake that contains 60% H2O, 200 kg of water is removed. And it was found that the fish cake has 20% water. The industry asks you to calculate the weight of the fish cake initially put into the dryer. Okay. So again, this is the material balance question, and we will use similar methodology to solve this question as well, like we used in the previous one. So first, what we'll do, we will draw a box that shows, or draw a small schematic diagram that shows what all things are going in and what all things are coming out. So this is the box that I was talking about. What is coming in here is the samples containing fish and water, right? And it is, let's say, the weight of the finely grounded fish cake is A, that is coming in into this dryer. And initially, it contains how much of water? So if we write the mass fractions, water has a mass fraction of 0.6. So the remaining will be definitely cake. So fish cake has a mass fraction will of 4. So there are only two components, water and fish cake. So after the initial material passes through dryer, what is happening? What is coming out? Water is coming out. Okay, let me write it as H2O. H2O is coming out. And what is the weight of the H2O? It is 200 kg. After it is dried, the final product, let's say the weight of the final product is B, okay, and it has now water mass fraction of 20% or zero point 0.2. So ultimately, cake will constitute 0.8 of the total mass. All right. So this is how we represented the information given in this question in form of a diagram. Through now using this diagram, we will start solving the question by forming equations and finding the unknowns. So for this, first we have to assume a basis. Assume what? Assume that this calculation is valid only when for 200 kg of water removal. Okay. Suppose we don't take that assumption, then it will complicate the situation because the dryer can be heated up to, let's say, a higher temperature and more water can come out, right? So then this calculation that you're making won't be valid. So that's why I'm taking a basis that 200 kg of water removal is done, okay, and the calculation that I'm making is valid for this condition only. This is the condition that I'm giving first. So this is the basis. Then we will do mass balance. So there are two components here. Mass balance for water. Let's do mass balance for water. So the input, the incoming material, it is A here, which is unknown. A has 0.6 percent, that is 60% of water. It is coming, but whereas as it passing to the dryer, 200 kg of water is getting rid of. So on the right hand side, you will write 200 plus, in the product, you will see that only 20% of the water is remaining. So zero point 0.2 into B. So this is your first equation containing the variables that you don't know the value of. Second, for the fish cake, this is the second mass in our process. For the fish cake, what's the situation? Inlet has 40% mass containing fish cake. None of the material is getting lost. So uh, nothing is coming out, uh, whereas the final product has 80% of its mass, that is fish cake. Okay, so this becomes your equation 1, this becomes your equation 2. So let's simplify equation 2 first. So what you get A is equals to 2B, right? So this is simplified. Let's call it as equation 3. Let's substitute 3 in 1. Okay, so we will basically write the value of A here. So it will be 2B into 0.6 equals to 200 plus zero point 0.2 into B. So the entire equation is now in having only one variable, correct? So let's get the value of B now. How will we do it? We will do further simplification. Just have a look what I'm doing. All right. So we get value of B, that is 200. So what is 200? 200 is kgs. So 200 kg of the final product you are getting. But what is asked here? You are asked what is the weight of the fish cake that you put in initially. So you're still not done yet. You have to still go further and get the value of A. This is your answer basically. Okay, this is your answer. So let's get the value of A from equation 3. A is equals to 2 into 200, that is A equals to 400. That means initially you have put in 400 kg of fish cake, 200 kg of water has been removed, and remaining 200 is the final weight of the product. Okay, containing only dried fish cake. Understood how I solved this problem? Okay. Now moving on, this is the seventh question that we have. There is a cereal product that contains 60% water. Okay. And this product is prepared at the rate of 600 kg per hour. You are asked to dry the product so that it contains only 40% water. How much water has to be evaporated per hour? Okay. So again, this is a mass balance types question. So let's draw a similar diagram. This is your box through which something will go in, something will go out. So let's say this is something, okay? Your product, your cereal product is being dried here. So let's make this is a dryer. And into this dryer, you are putting in cereal that is being prepared at the rate of 600 kg per hour. Okay, so this is your flow rate of cereal that is going in, or mass flow rate of the cereal that is going in into this dryer. It has a water content of 60%, that is zero point 0.6 is the mass fraction. So remaining is your cereal, that means it is 0.4. After it is dried, the final product, the final product has uh, water content. Final product has water content which is 40%. So let's say the flow rate or the mass flow rate at which the final product is coming out is B, and it has a mass fraction of cereal that is 0.6. So you have to calculate the amount that has to be evaporated. So what is coming out? One more component which is coming out is your water, right? That you have to calculate. You don't know. This has to be calculated. How will we do it? Again, similar methodology, step by steps will remain the same, but some tweaks has to be made. Let's take a basis of 1 hour, means the entire calculation is valid when the process is monitored for 1 hour. So under this 1 hour basis, let's do mass balance for water first. So the initial product, so initial amount of cereal, there is 60% water, so 0.6 into 600, and you don't know how much water is coming out. That is the variable that we have to get. So let's denote it with W. So W is the second variable that is coming out, and the final product has 40%. Okay, 40% of the total mass. So this is your first equation. Then for cereal, when you do the balance, what you get, the methodology, the logic remains the same. So the cereal, nothing is getting lost. So the final product will have the all the cereal amount. This is your second equation. So you have now two variables and two equations. So let's first solve 2 in order to get the value of B. So B is equals to 240 by zero point 0.6, correct? So if you do this calculation, you will get B equals to 400. So it has to be represented in the unit of 400 kg per hour. This is the flow rate, or the mass flow rate at which the cereal is coming out. This is B. And let's substitute the value of B in 1. So what you get, you will be able to now calculate the value of water evaporated, correct? So let's do this. It's pretty easy. You have to just shift the value from right to left, and it will be something like this. And the final answer that you will get is 200 kg per hour. All right. So this is the answer. This is the amount of water that is evaporated. This is the mass flow rate of the water that is evaporated. 200 kg per hour. Okay, understood? Understood?
Yes, ma'am.
Good. I hope you are following along with the steps and you are doing it yourself as well. It will give you a much better understanding. Okay. So moving on, this is the eighth question. So I have around four more questions left for today's session. This is the eighth question. You have to do unit conversion. Okay. A car is traveling at the speed of 90 kilometers per hour. Okay. You have to convert this speed in meters per second. Pretty easy. So 90 kilometer per hour. So it can be written as 90 kilometer per hour. Now you know 1 kilometer is 1000 meters and 1 hour is equals to 300 seconds. You know this, right? So let's plug in. So uh yes, sorry. I- So you know 1 kilometer is 1000 meters and 1 hour is 3600 seconds. So in this way we wrote all this and cancelled out the common units. So what we are left with then is equals to 90 into 1000 divided by 3600 meter per second. If you do a simple calculation, it will come to be 25 meter per second. Kindly check from your end if you got the same answer. You got the same answer?
Yes, ma'am.
Okay. So moving on, this question that I have is on dimension analysis. So the question states that the period T of a simple pendulum, T is basically the time taken for it to complete one oscillation. Now T depends on the length of the pendulum L, the mass of the bob M, and the acceleration due to gravity G. So you have to use dimension analysis to determine how the period T depends on these values. So it's pretty easy. First, we have to uh, like basically write in equation form what the question is stating here. T is directly proportional to L, right? Length. Let's say some power, we will have to calculate this value of power. So let's say it is alpha into m raised to the power beta. M is the mass of the bob, and g is the acceleration due to gravity, and it has the exponent of gamma. So as we are going to do the dimension analysis, the value of alpha, beta, and gamma are going to be get revealed to us, and we'll use those values to get the final expression for t. So it is proportional. So let's remove the proportionality sign by adding a dimensionless constant or the proportionality constant k. So now this equation is rewritten as this. All right. So I'll take one page here. Yes. Okay. So t basically is time. So it can its dimension is t as it is. K is dimensionless. So no need to worry about it. L is the length. M is the mass. What is the dimension of acceleration? We have to use that. So acceleration dimension can be determined by using its definition, that is velocity by time. Dimension of velocity is length L t raised to the power minus 1, because velocity is basically distance by time, and then time is t. So dimension of acceleration is this. Just put it here, right? And so this is the equation in the dimension quantities, in the form of dimensions. So we have to write equations for alpha, beta, and gamma. For so to do that, we will take L, M, and T first, one by one. So for T, you see it has exponent of 1, and then exponent of minus 2 gamma. Let's say this is your first equation. For L, on the left hand side, there is no L quantity. On the right hand side, there is alpha, right? And gamma. Okay, this is your second expression. Now for M, the left hand side, there is no M, and then there is beta here only. This is your 3. So the expression 3 or the equation 3 is pretty much solved. We are able to understand that beta is 0. We have to just now calculate the value of alpha and gamma. So solve 1, we get gamma is equals to minus 1 by 2, and solve 2 equation, what we get, alpha is equals to minus gamma, that is half. So finally what we got, alpha is half, beta is 0, gamma is minus half. Now when we substitute these value of alpha, beta, gamma in the dimension expression, what we get, t, or in the not in dimension, let's say directly in the first expression, this is your I'm talking about this expression. When we fit in this expression, what we get? Period T is equals to K into L raised to the power alpha. Alpha is half here. Now M mass raised to the power beta. Beta is 0. G raised to the power gamma. Gamma is minus half. Or T is equals to K into root L by G. Okay. So this is the expression stand how T is like value of C is dependent on L and G. It is not dependent on the mass. Okay, understood?
Can you please explain answer?
Yes, sure. So the question asked uh, to answer how the pendulum period T depends on three parameters: length of the pendulum, mass of the bob, and G, acceleration due to gravity. It asked us how it depends on these three parameters. In order to show the dependency, we are doing dimension analysis. So dimension analysis, it is you must have studied in +2 as well, where we can express each quantity in physics like acceleration, velocity, power, energy in terms of dimensions, which has mass, length, and time. That's it. So we are using that concepts here only. So this is so what we are doing first we are assuming that this is how the dependency will be. This is how T is dependent on L, M, and G, where alpha, beta, gamma are unknowns for us. We are going to calculate the value of alpha, beta, gamma in the next step. The value of these alpha, beta, and gamma will help us derive the expression that answers how T depends on length, mass, and G. Okay. So then after, if you have understood this, the rest of the process is pretty simple. You have to write each of the quantities in the expression in its dimension form. So I have done that first. Okay, in this line you can see I've written each of the quantities in its dimension form. Now for alpha, beta, gamma, I have framed some expressions by taking into account where it is, whether alpha is an exponent of L, M, or T. By looking at that, I have formed these three expression 1, 2, and 3. So for T, this is the expression where in the left hand side there is 1T, so it is 1 exponent is 1 is equals to minus 2 gamma because here the exponent of T is minus 2 gamma. Similar logic has been used to get expression 2 and 3 as well. So when you solve these three expressions now, you will get the value of gamma and alpha and beta also you got. So these are the values. So I just did that, like work is done. So in order to get the final answer, I had to just plug in these values of alpha, beta, gamma in T. That's it. So I did that. And so this is your final answer. Got it? Great.
Yes, ma'am.
Yeah. Um, So this question, this is I'll the formatting of the software must have disrupted the way this question is displayed right to you. Okay, but I'll read it out the full question. The part of this question is cut basically. Okay, so I'll read it out. Calculate the result of this expression. This is the expression. Expression is correct and express the answer with the correct number of significant figures. So it's the same problem that we have done previously as well. Why don't you start and tell me the answer first? Then I'll do it. Sounds good? Sarmata, that sounds good. Yes? Will you be able to do it?
No, ma'am.
No? Why? You didn't understand the previous questions that we did on this concept? Hmm? Tell me what's the issue? You have a calculator with you, right? Okay, just take the calculator and tell me what's the answer of this expression first. Okay, we'll do it together. Don't worry. Just tell me first what's the answer of this expression.
Ma'am, 0.023.
Wait, let me write 0.023. Done? Anything remaining? Done? Why don't you take a minute to cross check? Correct?
Yes, ma'am.
Okay. So, this is your answer. Now tell me, uh, how many, so this is the answer that you got from your calculator. Okay. So now tell me, how many significant figures should be written here in order to be correct in terms of significant figures? So how do you do that? We have to first check how many significant figures are there or digits are there in each of the numbers that we started with. So the first number, there are four significant figures. In the second number, there is again four. The denominator has two. So we have to express the final product, sorry, the final result in terms of two significant figures. Now tell me, is this answer correct? Does it have two significant figures?
Yes, ma'am.
Yes. So you were worried that you won't be able to do. It's easy. You have done it. All right. By the way, the answer that you got 0.023, I think is incorrect, because when I did it, I got around 0.052. So once again, after the lecture, please cross check. Okay. But the purpose of this question is just like done. Okay. So this is the second last question. After that, we'll be done for today. Calculate the molarity of a solution prepared by dissolving 15 mg of caffeine in 25 ml of water. Okay, so the molecular weight of caffeine is given to us. We have to calculate molarity. So what is molarity? Yes, what is molarity? Is number of moles by volume. Usually we calculate molarity to be amount of the number of moles in 1 liter of solution. Okay, but in for simplicity, I'm just writing it as volume. Okay, this is like expression for molarity. So for getting molarity, we have to first get the number of moles. We are given mass and we are given the molecular weight. So using these two information, we have to calculate the number of moles. So how will we do that? The mass of caffeine is 15 mg or 0.015. You must make sure when you are doing calculations, the units are similar. Okay. Otherwise, you will mess up later on. This is your mass. I have converted into grams. And the molecular weight that is given is 194.19 gram per mole. You can consider molecular weight as IE. It can be also understood as 1 mole of caffeine has 194.19 grams of caffeine. Okay, you can understand molecular weight in this way as well. So if 194.19 grams is equivalent to 1 moles, then 0.015 gram is equivalent to how many moles? That's the question now. Okay, so the number of moles of caffeine will be 1 mole by 194.19 into 0.015 grams. This is also grams. So you will get, so when you write this expression in this way, what you will get the final result or the final answer in terms of moles. So I have previously done it. So the answer that I got was 7.7 into 10 to the power minus 5 mole. All right, this is the number of moles of caffeine in this particular solution. But we are not done yet. The volume that we are given is in what? Is in 25 ml. I told you in molarity we have to take volume in liters. So we have to convert 25 ml into liters. So we know 1 liter is 1000 ml. 1 liter is 1000 ml. So 25 ml of volume is 0.025 liters. Okay, so you got the number of moles, you got the volume. We have to just plug in these two values to get the molarity now. So 7.7 10 to the power minus 5 divided by 0.025 mole per liter. So if you do the calculation, what you will get? You will get approx 0.3.08 into 10 to the power minus 3. Okay, take a second to absorb what you see in front of you, and you have any doubts, ask.
Ma'am, no doubts, ma'am.
Doubts? Great. So this is the last question for today's session. A chemical processing plant uses a rotary dryer to reduce the moisture content of wet solid. Initially, the wet solid contains 70% water by weight. All right. After drying, the solid contains 30% water by weight, and 500 kg of water has been removed during the process. So calculate the final weight of the dried solid coming out of the dryer. So it's very similar. We have done a very similar problem previously as well. Okay, so let's start. So let's consider this is a box, and this box is your dryer, and in this dryer, wet solid is going in. The mass of wet solid, let's say, is A, and it has a water content of 70%. So the mass fraction of water is 0.7. As it is dried, how much? 500 kg of water has been removed. Okay. And remaining solid now has mass of B kgs, and the water content it has is 30% or 0.3 mass fraction. Okay. So the water is this, then we have to just calculate what is the final weight. So we have to calculate the value of B. Find what is the calculate the final weight of dried solid coming out of the dryer. All right, let's assume basis where 500 kg water is removed. Okay, and let's do mass balance for water first. So the first equation would look like this. Okay, this is the first equation. But now since there are two unknowns A and B, we need another equation. To write the another equation, we have to consider the mass fraction of solid as well. So the inlet of solid has around zero point 0.3 or 30% by weight, the solid content, and outlet has around 0.7. We have to consider these two uh, facts as well. So for wet solid, a solid balance, the second equation would look like this. This is your second equation. And now you have two equations and two unknowns. Let's solve it. Um, Solve equation 2. What we get? A is equals to 7 by 3b. Okay. Let's substitute. Let's write it as equation 3. Substitute 3 in 1. What you get? 0.7 into 7b by 3 equals to 500 plus 0.3b. So now b will be what? It will take few more steps to get the value of b. Let's do them. Hmm. So 500. So take a calculator. 0.9. So it's 4b by 3 is equals to 500, and b is 1500 by 4. That is 1500 divided by 4. And I plugged in the value in my calculator and I got 365 kg. That is the value of uh, B. Hmm. I think I did something wrong. Wait a second, let me check. Hmm. Okay, yeah, no, I did correct. Okay, this is the value of B. So when you plug in the value of B in equation, put in equation 3, A is 7 by 3 into 375. So this, so A is 875 kg. Okay, A is 875 kg, and that is the answer. Sorry, so our answer is for this question is this 375 kgs of solid, dried solid is coming out of the dryer, whereas 875 kgs of dried solid was initially put in, and 500 kg of water was coming out. So if you do a total balance, it will be much clear, like 865, 875, that is A, is going in, and 500 kg of water is coming out in B. So here if you put in 875, 500 plus 375. So these matches, right? The values of A and B that we got, it matches with this equation. Both LHS is equals to RHS. Okay. Any doubts?
No doubts, ma'am.
No doubts. Okay. So this was the end of today's session. Okay. If you have any other queries uh, related to the topics that you have gone through in this week, or if you want me to discuss something else, if you want me to discuss some more problems related to any topic, I'll come prepared in the next session. Anything that you want to, everything okay? Any doubts, anything, let me know.
No doubts, ma'am.
No doubts? Okay. So then let's wrap up today's session. All right. And thanks for joining. And I hope you are able to, when you go back now, you will be able to solve assignment one. Next week, if you face any doubt in solving assignment one problems, um, I can discuss assignment one problems only after the solution is released. So after that, I can help you with assignment one problems as well. Okay. Next week, we'll discuss predominantly week two content and problems related to week two topics. Yes. Anything you want
Yes,
to
ma'am.
add? Yeah. Okay.
Thank you,
Okay.
ma'am.
Yeah. Thank you for joining. Yeah, I'll end the meeting. Yeah.
Thank you, ma'am.